paper 11. Let's take a look at question number 1. Use the standard result from the list of the formulae MF19 to show that the series over here is equal to the an cubed plus the bn squared plus cn, where a, b, and c are integers to be determined. Okay, so what we need to do over here is just to expand the expressions of the inside the series over here, 5 minus 3r. So if you expand them, you will get this as the 10 minus the 21r plus the 9r squared. Okay, so over here, you just need to use the formula booklet, split them one by one. This one, you get this as the n plus 1 over 2. 21. This is a 21. Then this one is a 9n, n plus 1, 2n plus 1 over 6. Okay. So over here, we just need to be careful with this. I miss out the n here. This is a 10n. So simplify them, you get a 10n minus a 21 over 2n squared minus the 21 over 2n plus the 3 over 2n 2n squared plus the 3n plus 1. So if you keep on expanding, you will get 10n minus the, I think this one we can join together. The 10n and the negative 21n, we can join them together. So we will get this one as a negative half n minus the 21 over 2n squared plus the 3n cubed plus the 9 over 2 n squared plus the 3 over 2n. Okay, then continue to simplify it. You get 3n cubed minus the 6n squared, then plus with the n. So just like that, done. So this will be the answer for the question number 1a. Now we move on to the question number 1b. Use the method of differences to find these expressions at the series over here in terms of n. So what we need to do is that we know this one can be done by using the partial fractions. So we will be using the partial fractions over here. Make it become a over the 2 minus 3r plus the b over the 5 minus 3r. So you will get this form and this 2 minus 3r. So when r is equals to the 2 over 3, then you get, when the r is equals to 2 over 3, then you will get this one as the 1 equal to the 3a, and your a is 1 over 3. When the r is equals to the 5 over 3, then you get the 1 is equals to the negative 3b. Therefore, you get the b is a negative 1 over 3. Okay. So we just need to write down this series. 1 over the 2 minus 3r multiply the 5 minus 3r can be decomposed into 1 over 3r, 2 minus 3r, 1 over 3 divided by 2 minus 3r minus the 1 over 3 divided by 5 minus 3r. So they have a common factor, which is a 1 over 3. We can factorize it out. That makes this inside here become 2 minus 3r minus the 1 over the 5 minus 3r. So what you need to do is to show the value. If you put 1 inside, you will get -1. If you put 1 inside, then you will get a half. Now if you put 2 inside, you will get -1/4. This one you will get a +1. And if you put 3 inside, you will get -1/7 minus the 1/4, plus the 1/4. Okay, so you can see the pattern of the cancellations. These two can cancel, these two can cancel. So we can foresee that the pattern of the cancellations will continue in such a way. Then we need to write down the last two terms. So the last term, it will be 1/2 minus 3n minus 1/5 minus 3n. And the previous term, it will be 1/5 minus 3n minus the 1/7 minus 3n. So you can see that the pattern of the cancellation will remain in such a way. So at the end, you get this one as a 1/3, 1/2 minus 3n minus the half. So you get this minus a 1/6. Okay, so this will be the answer for the number 1b. Okay, so now we move on. Deduce the value of the series over here when they approach to infinity, when the n is approached to infinity. So what you need to do is just to write down this expressions, just write down. Then telling that this limit of n is approaching to infinity, make this become n. And then from the part B result, you know that this is actually 1/3 of 2 minus 3n minus a 1/6. So when the n approaches to infinity, you get 0 minus 1/6. You get -1/6. Done. This will be the answer for the question number 1C. Moving on, we have a question number 2. Find the new cubic equation whose roots are alpha cube minus 1, beta cube minus 1, and gamma cube minus 1. So what you need to do over here is, first of all, we just let this y equal to the s cube minus 1. Then you will get the x is equals to the y plus 1 power of 1/3. So we're going to substitute this into the original equations. Then you will get this one as a y plus 1 power 1/3 cube plus 2 of the y plus 1 cube root plus 1 equal to 0. So if you expand them, simplify first before you expand them. Then you will get 2y plus 1 cube root is equals to the -2 minus y. So in order to make it the positive integer of the power, we will cube for both sides. So if we cube for both sides, then we will get this. So you will get 8y plus 1 is equals to the negative of the y cube plus the 3y squared times 2 plus the 3y times 2 squared plus the 2 cube. Expand, simplify, then you will get y cube plus the, I put a negative here. This one, it will be negative y cube minus the 6y squared minus the 12y minus the 8. This will be 8y plus 8. So at the end, you will get y cubed plus the 6y squared plus the 20y plus the 16 equal to 0. So this will be the answer for the question number 2a. Moving on, we have a 2b. Find the values of the for these expressions over here. So what you need to do is just to let using the formula, because we know that the a squared plus b squared plus the c squared is actually a plus b plus c squared minus a 2ab plus the ac plus the bc. So we will be using these relationships. Then we can get this one as the alpha cube minus 1 plus the beta cube minus 1 plus the gamma cube minus 1 square minus of 2 of the alpha cube minus 1 beta cube minus 1 alpha cube minus 1 gamma cube minus 1 plus the beta cube minus 1 and gamma cube minus 1. Okay, so all this we can find it from the answer in A. So this will be the A plus B plus C. Okay, this one it will be negative 6. This one it will be AB plus the AC plus the BC is equal to the 20. So over here you will have a negative 6 square plus minus the 2 times 20. So you get 36 minus 40, you get negative 4. So this will be the answer for the B. Moving on, we have question C. Find this when the expression is the cube. So what you need to do is to let Sn equal to the alpha cube minus 1 power n plus the beta cube minus 1 power n plus the gamma cube minus 1 to the power of n. So from the equations that we have in part A, we get this one as a 6y squared plus 20y plus a 16. That means I get a y cube equal to the negative 6y squared minus a 20y minus a 16. So we can make it become S3 equal to the negative 6S2 minus a 20S1 minus a 16S0. So we are looking for S3 actually. This is S3. And the value just now over here actually was S2. So the S2 is a negative 4. And what about S1? What about S0? S0 is actually 3. Okay, so S1, it will be from here. This is the S1. S1 is a negative 6. Okay, S1 is a negative 6. So we just replace the negative 6 inside. And just press the calculator. You get 24 plus the 120 minus the 48. Then you get this answer is 96. Done. This will be the answer for the question number 2. Moving on, we have question number 3. Okay, question number 3. We have the sequence of a U1, U2, U3, and so on, such that the U1 equal to 5 and the UN plus 1 equal to the 6 UN plus 5 for n greater or equal to 1. Prove by induction that this relationship is true for all positive integers n. So we start from n equal to 1. N equal to 1, you just write U1 is equal to the 6 power 1 minus 1. You get a 5. It's the same as this value. So we just say that true for n equal to 1. Then assume true for n equal to k. Then you will have UK will behave as a u power k minus 1. Then when n equal to k plus 1, your uk plus 1, we will be using this relationship, is equal to the 6uk plus 5. And you replace this value inside, you will get 6 power k minus 1 plus 5. And then you get this as the 6 power k plus 1 minus 6 plus 5. And you get the expression that you want. True for n equal to k plus 1. So conclusion, by the BMI, the un equal to 6 power n minus 1 for positive integers n such that the u1 is equal to 5 and un plus 1 equal to the 6un plus 5 for all n greater or equal to 1. So this will be the answer for the question number 3a. Now move on. 3b, deduce that the u2n is divisible by un. So the u2n, according to what we have proven, is a 6 power 2n minus 1. We can make it become 6 power n squared minus 1. We can factorize it, becomes 6 power n minus 1 and 6 power n plus 1. And this is a un. Okay, just like that. Then after that, you can see that, therefore, u2n is divisible by the un for n greater or equal to 1. That will be the answer for the number 3b. Moving on, we have number 4. Between these two matrices, where the theta is between 0 to pi, 0 to 2 pi. Then the matrix M, represented by the sequence of two geometrical transformation in the xy plane, state each of the transformation and make clear other in which that they are applied. So we need to state the transformations over here. So we know that this one will be first, followed by this one second. So the first one is the transformations. So we just say that this one is a transformation, a rotation. No, sorry, not a transformation. It's a rotations. This is a rotation. Anti-clockwise. Center at the origin. Through angle theta. Followed by this transformation. This is a shear, followed by a shear with x-axis fixed with the point 0, 1 mapped to 2, 1. It means originally your unit square is this, then it has converted into 1, 0, 2, 1. That means this 0, 1 have mapped to the 2, 1. That is the meaning of it. Okay, so you need to use the term followed by to connect the two transformations together. That will be the answer for 4a. Now we move on to the 4b. Find the value of theta which the transformation represented by M has a line of invariant points. So invariant points, for invariant points, that means the xy, it will transform to xy. So first of all, we need to find the M in one matrix. So 1, 0, 2, 1, multiply cos theta, sine theta, negative sine theta, cos theta. If you multiply them, you will get this one as the cos theta plus 2 sine theta. This one is a sine theta. This one is a negative sine theta plus 2 cos theta divided by cos theta. Okay, so first of all, we need to combine them, become one matrix. Then after that, for invariant points, that means the M here, the cos theta plus 2 sine theta, the negative sine theta plus 2 cos theta. This matrix for invariant points, if you transform xy, then you will get back xy. That is what you need to know. So if you expand them, you get cos theta plus 2 sine theta x plus the negative sine theta plus the 2 cos theta multiplied by y, you will get x. Okay. Then another one, it will be sine theta multiplied by x plus the cos theta multiplied by y will give you the y. So what you need to do over here is to solve the simultaneous equations. Well, maybe we can call this one equation 1, and this one we call it equation 2. But before that, I need to do the, I know that I need to do the simultaneous equations. So I make my y equal to the sine theta and 1 minus cos theta. I call this one equation 2. Then 2 into 1. Then I will have cos theta plus 2 sine theta x plus the negative sine theta plus 2 cos theta multiplied by the y, which already changed into this, is equal to x. So all the x will not equal to 0. We cancel all the x. Then we get this one as the cos theta plus 2 sine theta plus the negative sine square theta plus 2 cos theta sine theta divided by the 1 minus cos theta is equal to 1. So I need to multiply every one by 1 minus cos theta. So I will get this one as a 1 minus cos theta multiply cos theta plus 2 sine theta minus the sine square theta plus the 2 cos theta sine theta equal to 1 minus cos theta. So just have to expand them carefully. You get cos theta plus 2 sine theta. I want to expand these expressions carefully. So I get cos theta plus 2 sine theta minus the cos square theta minus the 2 sine theta cos theta. This one done. Okay, this one totally expanded. Then this one is minus the sine square theta plus the 2 cos theta sine theta is equal to the 1 minus cos theta. So you can see that these two can be cancelled. And you bring one side. You bring one side to make it become 0. Okay. Make one side to become 0, then you will get this one is a 2 cos theta 2 cos theta plus 2 sine theta minus the cos square minus the sine square equals to 1. Okay. Then you know that this is a 1, is a negative 1. So over here, we will get this one as the 2 cos theta plus the 2 sine theta is equal to 2. And then the cos theta plus sine theta is equal to 1. So we need to solve these equations. Cos theta plus sine theta equals to 1. So now how to solve this? So over here, if we want to solve it, so we may continue over here. We square both sides. Then you will have a cos square theta plus the sine square theta plus the 2 cos theta sine theta equal to 1. And since this is a 1, that means the sine 2 theta will get 0. Okay. Now in our space. So over here, we will have sine 2 theta equal to 0. You have a sine 2 theta, 2 theta will be equal to 0 by 2 pi. And if you divide, you will get this. And because the theta is between, they mentioned over here the theta is between 0 to 2 pi. So we will only take this answer. Okay. So because of the theta between 0 to 2 pi, therefore your theta is only pi over 2. But maybe you can say that this one is also 3 pi, 4 pi, 3 pi over 2, and 2 pi. So these 3 cannot be accepted because they will not give you 1. Okay, if you replace theta equal to pi inside, it will not give you 1. If you replace theta equal to the 3 pi over 2 over here, it also will not giving you 1. Only the pi over 2 will give you 1. So therefore, the answer is only pi over 2. That's all. So this is the answer for the number what? Number 4B. Okay, done. Now move on. We have question number 5. Have the curve C that has a polar equation that look like this. So what you need to do, they ask us to sketch a C. So usually we will draw a table. Just need to put in the necessary value of theta and to find the R. So we can start from 0, then pi over 2, then pi, then we have a 3 pi over 2, then we have a 2 pi. So you press the calculator over here, you get 0, you get 1.9. Just one decimal place is enough. 1.7, 8.5, and 13.8. So you can see that the radius is getting bigger and bigger. So when we draw it, we need to make sure we have a proper scale. So because I draw in freehand, so it's not need to draw it properly as well. If we need to have a proper scale, but since I draw freehand, not able to give a proper scale. So I can only have, let's say 1, 2, then this one is something like that. Okay, maybe we just need to sketch it carefully. So the radius over here can up to 13.8. So it's a 2, 4, 6, 8, 10, 12, and 14. Okay, then this one is 2, 4, 6. This one is a 2, 4, 6, 8. So the first one is origin 0, 0, and then this one up to when this one is the theta equal to the 0 initial line. This one is the theta equal to the pi over 2. So it's somewhere here. Then 4.7 is somewhere here. Then 8.5 is somewhere here. Then 13.8 is somewhere here. So you can just draw the diagram. It's actually a spiral. Okay. So you need to draw properly because I draw in freehand. My scale may not be so proper. So this will be the answer for the 5A. Moving on, we have 5B. Find the area of the region bounded by the initial line and the curve, giving your answer in the form of this, where P, Q, R, and S are integers to be determined. So actually, this is the initial line. Bounded by the curve, that means we are looking for the whole area here. We're looking for the whole area over here. So we need to integrate the formula, half r square d theta, integrate from 0 to 2 pi. Okay, so over here we straight away write the area A is equal to the half r square d theta, 0 to 2 pi. So what is the r square? Your r is a theta e to the power of 1 over 8 theta squared. Then you will get this theta square e power theta over 4. So we need to use integration by part. So I just do it directly. I get this one as the 4 theta square e power theta over 4 minus the integrate 0 to minus integrate 2 theta 8 theta e power theta over 4 d theta. I put the limit value, I put the definite value 0 to 2 pi later after I finish doing the integration by part. So I do one more time. So this time I get minus 32 theta e power theta over 4 minus the integrate 32 e power theta over 4 d theta 0 to 2 pi. Then at the end, it's not already done. You get positive 128 e power theta over 4, 0 to 2 pi. Okay. Now, what I need to do over here is to substitute the value. Substitute the value inside. I get this one as a 16 pi square e power pi over 2 minus the 64 pi e power pi over 2 plus the 128 e power pi over 2 minus the 0 plus the minus the 0 plus the 128. Then multiply this inside, you get 8 pi square minus the 32 pi plus the 64 e power pi over 2 minus the 64 unit square. Done. So this will be the answer for the question number 6b. Question number 6b done. Now we want to go for question number 6c. Show that the furthest point from the initial line, at the point of C, the furthest, show that at the point of C, furthest from the initial line is this, and verify that this equation has a root between 5 and 5.05. So what we need to do is we just start from here. You are looking for the initial line. This is the initial line, and the furthest from the initial line is actually we're looking for y max. So y max, I need to find the y. To find the y, I need to have r sine theta. I multiply everyone by sine theta. So I multiply sine theta. Then I get this. Then I need to find the dy d theta. This one, keep the left and right. Keep the left and the middle, differentiate the right. Plus keep the left and the right, differentiate the middle. Plus keep the middle and the right, differentiate the left. This is what we have. So we can actually factorize the e power theta over 8 out. Then we can get 1 over 8 theta sine theta plus the theta cos theta plus the sine theta. Okay, that is your dy d theta. In order to get the furthest point, that means your dy d theta must be 0, which means that this must be equal to 0. And since the e power theta over 8 cannot equal to 0, that means the remaining one, this must equal to 0. Okay, so you just have to rearrange them, follow that what the questions want. Okay, just follow whatever the question wants. Oops, sorry. My apologies. Something wrong. Okay, so just arrange them again as what the question want. So you will have what the question want is theta cos theta plus the 1 plus the 1 over 8 theta, or not 1, theta plus 1 over 8. Theta over 8 plus 1, sorry. Theta over 8 plus 1 is a 1, is a 0. This is what the question wants. As shown, okay, so shown. Okay, then now we need to show that there is a root between 5 and 5.05. So now we just need to let the f theta equal to the theta cos theta plus the theta over 8 plus 1 sine theta. Using your calculator, replacing the 5 and 5.05 inside, changing the mode into the radian mode. So over here, if you press the calculator, this will give you negative 0.140. It's a negative value. And this one will give you positive 0.134. It's a positive value. There's a changes of sign over here. Therefore, there's a root in between. So just say that because of there is changes of sign between 5 and 5.05. Therefore, there is a root lies between 5 and 5.05. Done. This will be the answer for the question number 5. Now we move on to the question number 6. Find the equations of the plane ABC, giving your answer in the form of ax plus by plus cz equal to d. So what I need to do is I write down the OA as a 1, 0, negative 2, OB as a 1, 2, 2. I write them in the matrix form. OC is a 2, negative 1, negative 1. Okay, then to find the ABC, the equation of the plane ABC, I need to find AB, vector AB. Just take the B minus A. And find the vector AC. Just take the C minus A. Okay, so now I need to do the cross product of AB cross with the AC. I get this. 0, 2, 4, 1, negative 3, negative 3. Do the cross product, you will get 6i plus 4j minus a 2k. And you can see that they are all the multiple of 2. I can factorize a 2 out, make it become this. So therefore, my normal vector, it will be 3, 2, negative 1. Okay. So the equations of plane ABC, it will be the dot product. So we have a x, y, z. The normal is a 3, 2, negative 1, 3, 2, negative 1. Choose any position vector, either the OA, OB, or OC. I choose OA. Then I have a 3x plus 2y minus z equal to the 3 plus 0 plus 2. Then I get 3x plus 2y minus z is equal to 5. Done. This will be the answer for question number 6A. Move on. B. The point D has the position vector like this. D not equal to negative 2. We want to find the angle, acute angle between the plane ABC and ABD. Okay, so we already have the plane ABC. Now we just need to find the ABD. Okay, so ABD, just now the ABC, we need to take AB cross AC. Now this plane, I need to take the AB cross the AD. I already have AB. I just need to find AD. So from here, I need to find AD. The vector AD. Vector AD, just now the A was, this is the OA. 1, 0, negative 2. 1, 0, negative 2. So maybe I write OA here. 1, 0, negative 2. So AD will be the 0, 0, D plus 2. Okay. So I just need to take the AB cross with the AD. It will be, just now AB was 0, 2, 4. Then the AD is a 0, 0, D plus 2. So you can get this one as a 2D plus 2I plus the 0J plus the 0K. So we can actually factorize this one out, make it become 1, 0, 0. That means this will be my normal vector. I call this one normal vector number 2. That means I call this vector over here normal vector number 1. How do you find the acute angle between these two planes? So the formula will be the modulus of the normal vector number 1 dot with the normal vector number 2 square magnitude of this normal vector number 1 just now, normal vector number 1 just now is a 3, 2, negative 1. So 3, 2, negative 1. I have a 9 plus 4 plus 1. And then 1, 0, 0. You have a 1 plus 0 plus 0. So just use your calculator, simplify it. You get 3 over square root of 14 and square root of 1. From here, press the calculator. You can get the data is a 36.7 degree. Just like that, done. That is the answer for the number 6B. Okay, now we move on to the question 6C. Find the values of D such that the shortest distance between the line AB and CD is a 2. So they mentioned values of D. So that means we have more than one value of D. And they use a shorter distance between the two lines. So we need to know the formulas of shorter distance between the two lines. First of all, we need to have AB. AB we already have 0, 2, 4. But CD I don't have. CD just need to refer back again. This is the D. 10D. This is the C. So 10D. So to find CD, just take the D minus C. You get a negative 1, 1, and then D plus 1. Okay? Yeah. So this one, the CD is a negative 1, 1, D plus 1. Straight away, right? Negative 1, 1, D plus 1. Then I also need to take either take AC or take AB or take AD. But we don't take AD because D got a parameter D is difficult for us. So the easiest we will take either AC or BC. So we take AC. A, then plus a 2K. Okay, so this is what we have. So we can simplify them in a matrix form. We have a 2t minus 2, negative 4, and then 2. Okay, so the formula, the shorter distance between AB and CD. Is equal to the SAT2. So the formula will be the modulus Okay, so you need to take the AC. AC is a 1, negative 1, 1. Okay, just take this AC, dot with the cross product that we have found just now. 2t minus 2, negative 4, 2 is equal to the SAT2. And below here will be the magnitude. Okay, so this is what we have. So what you need to do over here is that the modulus, we have a 2t minus 2 plus 4 plus 2 modulus is equal to the square root 2. Square root of, you expand them, you have a 4t square minus the 8t plus the 4 plus the 16 plus the 4. So I square both sides. Before I square both sides, I think I need to simplify it. Become 2t plus 4. I square both sides, no more modulus. This one, it will be 2 and a 4t square minus a 8t plus 24. So if I expand, I get 4t square plus the 16t plus the 16 equal to the 8t square minus the 16t plus the 48. So you get a 4t square minus a 32t and plus a 36 plus a 32. equal to 0. Divide everyone by 4. Then you can find the t using the quadratic formula. It will be negative b plus minus of the b square minus a 4ac divided by 2a. So the t will be equal to the 4 plus minus of 2 sub 2. Okay, that will be your t. Okay, so therefore, your t is equal to the 4 plus 2 sub 2, and your t is equal to the 4 minus 2 sub 2. So these are the two values of t that we can find. And move on, we have question number 7. Need to do now over here is that first of all, I take the denominator out, that is equal to 0. Try to factorize it. And see that your x is equal to negative half and your x is equal to 4. That will be your vertical asymptote. Okay, then for the horizontal asymptote, you just need to let the y equal to the limit of x approach to infinity, 2x squared minus the 5x divided by the 2x squared minus the 7x minus 4, you will get y equal to 0. So this will be the vertical horizontal asymptote. Okay, so, sorry, this is a 1. I make a mistake. Y is equal to 1. So we have found the horizontal asymptote and the vertical asymptote. Now we move on to the part B. We want to find the coordinate of the stationary point. So for stationary point, we just need to do dy dx, quotient rule, keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. Simplify them first before we find the dy dx equal to 0. So over here, you had to simplify them carefully. So you have 8x cubed minus the 10x squared minus the 28x plus the 35. 28x squared plus the 35x minus the 16x plus 20. It's quite long, huh? I need more space. I will get 8x squared. I straight away combine together 8x cubed. Then for the x squared, it will be negative 10 minus 28, negative 38 x squared. And then plus the minus 35 minus 16. 35 minus 16, you get 19x. Then plus the 20. Then minus this one, if you expand, you will get 8x cubed minus 34 x squared plus 35x divided by the denominator. We're not going to change anything for the denominator, just copy down only. Simplify it, you will get negative 4x squared minus the 16x plus 20 divided by the 2x squared minus the 7x minus 4 squared. So for your dy dx equal to 0, you just take the negative 4 out. Okay, then factorize it. You have a x plus 5 and x minus 1. So your x is a negative 5 and your x is a 1. When the x is a negative 5, what is your y? When the x is a 1, what is your y? Just use a calculator to press it. When the x is a negative 5, you get 25 over 27. When the x is a 1, you will get 1 over 3. So therefore, your stationary point will be -5, 25 over 27, and 1 and 1 over 3. Just like that, done. That is the answer for the part B. Moving on, part C, we want to sketch the graph stating the coordinates of the intersections of the axis. So to find the coordinates of the intersection of the axis, you just need to say that when x is equal to 0, your y is 0. When the y is equal to 0, so you have a 2x squared minus a 5x equal to 0, which is giving you two answers. Okay, so this is your x-intercept and the y-intercept. We still need to test one more thing to check whether is there any intersections between the horizontal line and the curve. So we do one more thing. Other than this, we want to let the y equal to the horizontal asymptote, y equal to 1. So you get the 1 equal to the 2x squared minus a 5x divided by the 2x squared minus a 7x minus 4. You will get 2x squared minus a 7x minus 4 equal to the 2x squared minus 5x. So this one you cancel. You get -4 is equal to the 2x. Your x is a -2. Okay. So these are the points that we have. These are the points that we have. So now we are ready to sketch a graph. So again, I draw in freehand. The scale may not be proper. So just to remind you, in exam, you try to accommodate at least 60 or to 70% of the space given so that your graph will not be too weird. So over here, okay, so need to try to draw it properly. We have 1, 2, 3, 4. This is your vertical asymptote. This is your vertical asymptote. And your horizontal asymptote is 1. This is another vertical asymptote. This is the x. This is the y. So this one is a -1, -2, -3, -4, -5. Okay. Then your intercept 0, 0. Okay. 5 over 2. That means it's a 2.5 here. Your maximum point, x is a -2. Your y is a 1. Okay. So we have passed through this point, and this point. Then what else? You have a maximum point, minimum point. Just now maximum point is a -5, 25 over 7. So somewhere here. Then another one is 1 and 1 over 3. 1 and 1 over 3. Somewhere here. So just draw it properly. You will have a minimum point over here. After that, it passed through this. Then this one. Oh, sorry. I think I make a mistake. My vertical asymptote was wrong. My vertical asymptote was a -0.5 and 4. -0.5 and 4. So this is wrong. This is not my vertical asymptote. My vertical asymptote happened at here, -0.5. So your graph will be like this. And this graph will be like this. And the last part of the graph will be like this. Okay, so since I draw freehand, the graph may not be very nice. This one is a 4. This one is a negative 1. Okay, done. This will be the answer for the C. Moving on, we have a part D. They want you to modulus the graph. So to modulus the graph, we just need to duplicate the graph and then just need to reflect all the graph below the x-axis going up. So this is a negative half. This one is a 1, 2, 3, 4. Okay, this is a 1, negative 1, negative 2, negative 3, negative 4, negative 5. That is your vertical asymptote. This is your horizontal asymptote. Pass through here, pass through here, pass through here. Actually, this is not affected. So this part actually is not affected. Just draw it as usual. Just draw it as usual. The one that is above, the x-axis is not affected. We just draw it as usual. It's just that this one, when we draw it, we have to reflect about the x-axis. So this is the 4. This is the 5/2. This is a 0. This is a 2. This is a 1. Okay, so this will be the graph for the D. And then move on. We are looking for the E, solving the inequality. So to solve the inequality, usually we just let them equal first. So we will break them into 2 parts. One part is a positive, 1/9. Another part is a negative, 1/9. So just need to solve it. 18x squared minus the 45 is equal to the 45x is equal to the 2x squared minus the 7x minus 4. So you will get 16x squared minus the 45. You will get this as the minus the 38 plus 4 equal to 0. Using the quadratic formula, you will get this one as the, maybe all of them can divide by 2. So to make our calculation easier, we try to divide everyone by 2 first. So you have a 8x squared minus a 19x plus 2. Okay, not much of things we can simplify, but at least better than just now. Negative b plus minus of the b squared minus the 4ac divided by 2a. So we will have x equal to the 19/16 plus minus of the 3 square root of 33/16. Same thing happened over here. So we have 2x squared minus a 45x equal to the negative 2x squared. This one 18. Then minus a 7x minus a 4, plus and plus. So you simplify it, you get 20x squared minus the 52x minus a 4 equal to 0. Divide everyone by 4. Can divide everyone by 4. So you get 13x minus 1. Then using the quadratic formula, negative b plus minus of the b squared minus a 4ac divided by 2a. And you'll get this as a 13 over 10. Plus minus of 3 square root of 21 over 10. Okay. So we have 4 values over here. We need to arrange them properly. If you convert them into decimal, it will be easier to compare. If not, then you can see that if you arrange them in the ascending order, your x is actually 13 over 10 minus the 3 sub 21 over 10 is the smallest. The second smallest will be the 19 over 16 minus the 3 sub 33 over 16. Actually, you just convert to decimal, then you can see, you can compare the difference already. This is the third smallest. And this is the largest. Okay, so this one, they are in the ascending order. In the ascending order, okay? Now, from the graph, what do we need to do is actually we just need to go and draw the line of 1 over 9. 1 over 9 is over here. So you can see that the 1 over 9 is actually, there's a, let me enlarge this part. The 1 over 9 has a 4 intersection point. They are intersecting in this way. This will be 19 over 16 minus the 3 sub 33 over 16, and so on. And this one, it will be 13 over 10 plus the 3 sub 21 over 16 over 10. So your answer will be between here and here. Okay, so from the graph, actually we can see that. But actually we do not need to provide that into the solution. Of course, if you want, you can provide this diagram into your solution to make the examiner easier to check your answer. So just say that from the graph, your x is between 13 over 10 minus a 3 sub 21 over 10 to this. Another one will be 19 over 16 plus the 3 sub 33 over 16. And this one is the 13 over 10 plus 3 sub. Oh, I make a mistake. This is a 21. 21 over 10. Done. So this is your answer, final answer. And that will be the last question for this paper. I will stop the video here. I'll see you next time. Bye-bye.